Hello, everyone. Good afternoon and welcome to our first data engineering meetup of this new year. Hello, everyone. Good afternoon and welcome to our first data engineering meetup of this new year. You probably heard a bit of an echo, but second time welcome. So for the people who are joining more often, you will see a not so familiar face so far. I have a new co-host, and that's John. So we will be your two hosts for today. So we hope to make this meetup a smooth one. So we have today some awesome colleagues joining us from ING and from Go Data Driven. And we have some people joining us from Germany, and they will give a talk, and some colleagues from the Netherlands. So if you know the concept already a bit, after every talk we will do a Q&A. So if you have any questions, then you can ask them in the chat, and we will ask them after the talks. So I think that's so far it. So I would say let's start. John, can you start introducing our first speakers?
Of course. Well, welcome everyone. Thank you again. Our first talk is going to be by Fang and Tao. Tao is a machine learning engineer from the Frankfurt hub of ING, a night owl, a computer vision enthusiast by education, and a polyglot software engineer by career. He doesn't drink coffee, but he's not less productive than those who do. And Fang describes herself as a machine learning engineer, also from the Frankfurt hub, and she finds a passion in reversing entropy in a myriad of occurrences. She likes building stuff and doesn't like bugs. And I'm assuming it's computer bugs, but who knows? Today they will have a talk about computer vision techniques in information extraction. So please join me in giving a warm welcome to Tao and Fang.
Yeah, thanks a lot. Hello everybody. So we are Tao Rung, myself and Fang. So we are machine learning engineer from Frankfurt Hub. Today we're gonna go through techniques we use in information extraction, which we call a computer vision, and we're gonna go through a lot of techniques and a lot of knowledge that we also use in our own applications here. Just a quick introduction. So basically we are a group of 15 people. Half of them are data scientists and half of them are machine learning engineers. We have lots of machine learning related applications and project money. And over to Fang. So you can also give a bit of info about yourself and about the talk today.
Okay, thanks, Tao. Hello, my name is Fang Su. Like Tao, I'm also a machine learning engineer in Frankfurt Hub. So for this talk, maybe we can go on to the next slide. For this talk, we will start with a quick introduction to information extraction and the motivation behind it. And then we will talk about the two pillars of information extraction, namely computer vision and machine learning. In this talk, we're going to focus on computer vision. Then we will dive into basic image processing techniques in computer vision. And we're going to close with a use case of extracting geometry with computer vision in information extraction. All right, so what is information extraction? It is a way to derive information out of documents. The documents can be structured or unstructured or semi-structured, and it can be scanned documents and digital documents. The assumption or rationale behind information extraction is key information points are usually heavily decorated in documents. The reason for which might be we human like context and we like continuity. However, only those key information points are of interest to later downstream processing. And information extraction is a way to arrive at those key relevant information only. Okay, so the two pillars of information extractions are computer vision and machine learning. We do computer vision to enhance image quality, and we also do it to detect the structures to provide additional defining features for later machine learning. And we use machine learning also in information extraction to build our algorithms more generic. If you're a little not sure about how these two pieces fit together, we have a very friendly graph for you in the next slide. So this is a journey of a document going through information extraction. We start with a scanned receipt. As you can see, the quality is not very great. So we apply a bunch of computer vision techniques on it, like removing noises, enhancing the contrast. And after we're happy with the quality, we apply OCR, which stands for Optic Character Recognition on top of it, which leads us at a list of tokens. We call it tokens, but they are really just the words extracted from the images. And after that, we build machine learning models on top of it to arrive at the information that we're really interested in this case, amount and date. So now I will hand over to Tao to talk more about computer vision in depth.
Yeah, thanks, Fong. So technically, there are a bunch of techniques we use in the information extraction, and using machine learning is also one of them. But there'll be some parts that it comes into understanding what the image infer and information on it. Sometimes using the OCR to extract some of the text from the image may not infer all of the information we actually need. So let's get into the knowledge about the computer vision. So technically, what it is it is the sign of extracting some of the things or some of the information that lies on your images. It might be one single images or just stream of the images. We as human, when we see the image, we understand the key information on it, like the text. We understand what it says. We see the picture, we understand what it means. But for the computer, it only sees a bunch of pixels and a bunch of numerical numbers. But in order to make computer understand what it sees, we can use the technique we call computer vision. So to get you some brief ideas on the application of the computer vision and what it does, what kind of the capability it has, and any techniques that can be applied using computer vision, we can give you some examples here. So these are some of the examples of the usage in the computer vision in the field of extracting some information from the images. One of them are, we try to extract or segment some of the regions or areas from the images. Let's say, for example, we have the satellite images, and then we don't know anything else. We don't know any geographical information about it. We only know, the images. We can just use techniques of computer vision to segment the area of interest, like which blocks, roads are, located, and see the location of all of the roadblocks or the buildings, and we can use those information that we use the computer vision on it to reconstruct some of the useful model. And some of them, you may also see this application quite often, which is detecting the object. So given an image, as I mentioned, the computer may not know which pixels or which region belongs to the certain area of interest that the users may want to see. But we can use computer vision techniques to segment the area and detect what kind of objects it has in the it has in the image. Like for example, in this image, we can see how many human regions we have, how many cars, how many buses, and which regions also belong to the, let's say, buildings or whatsoever. That can also use the computer vision techniques as well. And not only the extracting or segmenting the areas of interest, sometimes we can also extract or remove some of the areas from the images which we don't want, because they might be considered noisy or might be considered something that may mask the useful information from the image. For example, in this example, we have the image, but we have some areas that we don't want. We can detect which one are useful information, which one are not, and then we try to remove all of the non-useful or some of the garbage from the image as well. And all of these techniques are kind of generic and can be applied to many use cases. And of course, when it comes into implementation, the people may have some common questions like, do we always have to invest in the deep learning in order to implement some computer vision techniques? Because there are so many deep learning architectures or techniques that they claim that they can use those kind of techniques to use for detecting objects or removing some noises or enhance the images or even extract some of certain regions of the interest from the image? The answer is quite simple. Not all of them. We don't always have to invest in the deep learning. We can also use some simple or fundamental of the image processing or computer vision techniques as well to detect something. And here comes the basic, fundamental things that we have to know beforehand before we start deep diving into the computer vision techniques. When we read the image, it can be a single image or a series of images from data sources. You want to extract some information on top of it. So it comes into a bunch of pixels containing numerical values. Depending on the depth of your images, you may work on the typical 8-bit or 16-bit, depending on data sources. And all of those pixels refer to some of the visual elements of the images. But if you look onto those, it just basically just n-dimensional matrix. You may not understand which part, infer some useful information. But if you look deeply, so in our case, for example, if we have a scanned image of some receipt, invoices, documents, or whatsoever, when it comes into, okay, we want to extract some of the useful regions, which in our case, let's say the black pixels, which represent the text or represent some useful information like logos or anything else. We can see the histogram of it, and then we can see, there are some, let's say, soft cutoff between the dark area, which are representing the text pixels, and the white area, which may represent the background pixels. And most of the cases, the quality of the scanned image or the photos that the users take may not, be really, really useful for the processing. So we have to find the best thresholding, values that we can cut off between the white and the black area. So here it comes into binary image pre-processing or extracting some information on top of the binary images. In most cases, you may come up with a lot of techniques that has to have the image which are binarized beforehand, because most of the cases we want the black pixels to represent nothing, represent no information, and we want the white pixels to represent the informative area. But as you see from the image, not all of them actually refer to a real useful area, because there are some noises as well. If you see the image on the right-hand side, you see a lot of noises, the white pixels. So there are also some techniques that we can just simply use, to remove some of the noise pixels, because if we process the noisy images, we may have a lot of data coming out from that image which may not actually refer to the real information you want to extract. So in order to remove all of those noises, not all of them, but some of the small spot of the white pixels, we can just use, sliding window, which we use in the convolutional operations. So we will need to define, the kernel. So in our case, if you want to remove some of the small spot of the white pixels, we can use Millen filter, and the size can be vary from 3 by 3, 5 by 5, depending on your resolution. And that techniques can remove some of the what we call is salt noise. And then we apply morphological operations to detect the connected component. Meaning, if you as a human look at the image on the left, you will see that there are some contiguous pixels that refer to the same object, like on the on the letter S, letter M, and etc. But as a computer, they don't understand which pixels actually belongs together as the object. So we can use morphological operations to detect all of those regions, separately. And here comes the most tricky part is, all of the or most of the computer vision techniques actually referring to the matrix operations. Yes. But most of them, we can use a lot of techniques that can be applied on the matrix as well. Then it comes into, how about after I remove all of the noises, I want to detect some useful information from the image. For example, in our case, if we have a scanned image and we see the tabular data, we can use OCR to detect locations and the values of all of the text, but not the table itself, how can we detect those table structure? Because it might be useful for reconstructing some structure information in a tabular form. Then here comes to the detection of some small shape like line detections. So in order to detect the vertical lines and horizontal line separately, we also have to use the 2D convolution as well, the same way as we detect the noises and remove them. But instead, we don't want to remove them. We just want to refine or reconstruct the vertical lines or horizontal lines by using the 2D kernels. So you have to define the kernel that you want to slide that window, that kernel on your image. And any pattern that looks like your kernel will be boosted. On the left-hand side of this equation, you see I have the given input image that may look like a bit of noisy vertical lines. You have some noisy white pixels as well, but most of them it looks like vertical line. And then you have a perfect 2D kernel that represents vertical line, a thin line. And then you do the convolutional operations, you will get the line pattern back. It also removes some of the noisy pixels as well. Also, it can reconstruct the broken part a little bit if it's not too bad. As you see, the missing pixels is also filled in. And how about if the input image doesn't infer any pattern we want to detect? For example, in this case, I have the input image which is super noisy. It doesn't look like any vertical line. If I apply the same kernel, I don't get anything back. Everything will be removed. So technically, using this technique, you can detect and boost the line patterns and removing some of the non-pattern area. That can be really useful for scanning through all of the image, and then you get the patterns you are looking for back. And the same thing, as I mentioned, we have to detect the vertical lines and horizontal lines separately. So we will have to run through vertical line detection using the vertical kernel and horizontal kernel separately. And then after that, on the top, you will see that the output from the vertical line detection, you will see the vertical line patterns will be reconstructed back, but leaving the horizontal line, out of the equation. But the same thing, the same image, if you apply the horizontal horizontal kernels, you will get that patterns that look like the horizontal line back. And the same thing, the areas that don't look like any of the horizontal line or vertical lines, you will get only the plain black pixels. And then here comes into integrating the results from the detections of the vertical lines and the horizontal line all together in order to reconstruct the table structure. So as you see from the example on the left, you will see here is the scan image of the invoice template, let's say. And from here, if you detect the vertical lines and horizontal lines separately, you can basically reconstruct the table back. So let's boil down into some steps. So first of all, we have to binarize the image first, as I mentioned, because the quality of the image might not be really good for the processing. The table frames, most of the times you will see it's not perfect black, but it sometimes comes into a different shade of grays or different shades of kind of super close to zero, but it's not absolutely zero. So those kind of the variations of the pixel values may have some difficulty when processing. So we have to binarize the values into 0 and 255 or 1, whatever, depending on what kind of the values you want to display. And after do the binarization, removing some noises, reconstruct the the lines on both directions, the horizontal lines and vertical lines. What you get back here on the right hand side, you see only the pixels that seems like to be representing the horizontal line or vertical lines will be detected, leaving anything else outside of your resulting image. But there will be some parts, if you look a little bit closely, a bit below the blue rectangle on the right, you'll see some of the false detection can also happen as well, but not all of them, because in some regions it may look a little bit like horizontal line patterns, but it's not. So, but those kind of noisy lines detection can be really easy to remove later. So for example, in our case, once we already have the binary matrix, then we can identify each of the lines separately by using the connected component, as I mentioned earlier. So technically, in these techniques, we can get the boundary and the position of each line separately. So we, given the input of the binary image, you will get list of the X line and Y lines back. And from those information, you can easily, reconstruct the lines back by, snapping the tips of the lines back to the grid of, you can create a grid from the information you already have. You have lists of the, the X coordinates and Y coordinates. You snap them all to the grid because the patterns may not include the corners of the tables. You also have to use this technique to reconstruct the full grid back. And after that, you can scan, from top down direction. And the boundary of the tables can be easily seen by the length or the beginning position of the vertical lines. Because in one image, it may contain more than one table. So you cannot always presume that there will always be one big table or small table or something like that. So using this boundary, you can detect different lines, different tables from from the list of the vertical and horizontal lines. And after that, you will see the region and list of the position of each of the columns and also the rows. And then you can use those information to reconstruct the table objects back, which is really, really easy to use. So in these techniques, what you get back is a list of the tables, and in each of the tables, you will know the region. Let's say XY coordinate of the top left corner. Also with list of the XY coordinates of each of the vertical and horizontal boundaries of each of the cells. So no matter you have, let's say, different templates or different number of the columns or number of the rows, you can also use this technique to apply to your image to detect, different ways of, how the table looks like. And then here comes into the combining with OCR. I would hand over to Fang.
Thanks, Tao. So now, after having at hand the table information, we can now put the words and tokens extracted by OCR into table context. So for instance, for the 2010 extracted from the top right corner of the document, we can see that it does not belong to any of the tables. So maybe perhaps it is not of particular interest to us, depending on the document type. Yeah, so one might ask, why do we do this? What is the benefit of combining table information, table reconstruction with OCR? So as we can see, that by doing that, we effectively created more features per token for later machine learning model building. Maybe we can move on to the next slide. Yeah, and this helps to pinpoint the areas of the interest and to limit the search space. And also it provides structural information from the image, which might provide as a shortcut around machine learning. So this concludes our talk. We hope by now that you have a good overview of information extraction and computer vision in information extraction. For the curious-minded, we have provided a puzzle repo as listed on the next slide, created by Tao. Maybe Tao, you can introduce it a bit more.
Yeah, so if somebody are interested in what kind of implementation it takes in order to put together all of the line detections and reconstruct the table out of the scanned image, here we have the sample of the repo that is written in C++ using OpenCV as the library that does most of the fundamental things in the image processing. So you can also look at the the prototype code that we wrote here and see how it works and see how it is implemented. There are also some guidelines how to use it as well. So you can also look through the slide that we are using here as well as a guideline on what kind of steps it has to take in order to detect all of the information that come into reconstructing as the table information and combining with the OCR. Hope this is useful for you, and if you have any questions, feel free to leave in the comments. We'll get back to all of those questions.
Yeah, thanks, Tao. Thanks, Fang. Thanks for a great presentation. During your talk, we actually had one question already from Lakshai, and the question was, what specific use case related to image processing interests you at ING?
Yeah, so within ING, actually, we receive a lot of documents from the customer as well, but not all of them, as you may already guess, not all of them are digital. So sometimes we have to detect or extract some information outside of, the digital area of the documents. So with the digital documents, it's easy because we can detect and extract the information out of the box. But for the scanned image, we have to use some combination technique to detect some of the tabular data and detect some of the tokens of the interest, let's say. So it has a lot of application in that area in order to detect or extract some useful information from the documents that the user submit.
All right, thanks for that answer. Well, for the rest, I see a lot of compliments for for a great talk and a nice explanation Robert just mentioned. Don't see any other questions right now. So let's give it 10 more seconds. If somebody can type in 10 seconds another question, and otherwise I'll, oh, right, yeah, no. All right, well then in that case, thank you very much for your talk, and good luck in all your computer vision quests going forward.
Yeah, thanks a lot.
Thanks.
Thank you.
Yes, so it's time for our next two speakers. We are having Mickey van Zeelt and Anand Kumar Singh. And they're going to talk about NLing engineering journey. To introduce you to our speakers, Mickey is a software developer and engineer from financial crime analytics at ING. While he loves automation and structure in both his work and personal life, he still has to get out of bed to make coffee anyway. Well, if you want to find a solution for that, let me know. And currently he is working with fraud at work and Swift at home. And Anand is a data scientist from Financial Crime Analytics, a team in Amsterdam from ING as well. A deep learning, this is a word I cannot pronounce, aficionado by education. He has developed a deep interest in automation during his time at ING. While he is natively a Python developer, he has recently started exploring C++ for parallel computation with CUDA. So again, they will talk about NLing and engineering journey. So welcome, Mickey and Anand, and the floor is yours.
Thank you, Jesse, for the introduction. So just to build up on that, I'm Anand. I'm like Jesse said that I'm a data scientist within the financial crime and RegTech department within ING. And today with with my colleague Mickey, I would present our product NLing, which used to be called Natural Language Interfaces for ING, but I thought that it did not really roll off the tongue, so we shortened it to NLing. It's a full text search engine built on top of Elasticsearch, and we spent quite a significant amount of time last year in 2020 to bring it into a test environment on the cloud and make it available to our stakeholders. Without further ado, let's begin. Just to give you a quick structure of the talk, just so that we can also make the time. I will start with the introduction to the product, and let's come to the agenda. We will start with the introduction to the product, and then Mickey would walk everyone through a little bit of infrastructure concepts, which will come in handy during the rest of the talk. And then we will talk about how we deployed like one unit of our product, which is a microservice, and then Mickey would talk about how did we deploy our central app or a conventional backend on the cloud, and followed by the front-end development, and we will conclude with some final parting words. We kept this GIF in here because it really captures any software engineer sentiments, in our opinion, who has tried to work on a deployment journey for his or her product. Okay, so moving on. All right, so like I mentioned, that NLing or natural language interfaces for ING started as basically a product for dealing with unstructured data. And just to give a little bit of context, as a department, we mostly deal with post-transaction monitoring, but we also deal with some customer screening and so on and so forth. So this entire product was built for customer due diligence. So with that in mind, we will be dealing primarily with unstructured documents, and unstructured documents vis-a-vis, in our case, it was PDFs. However, they were properly digitized PDFs. So just to refer to the previous talk, OCR, for instance, was also something that we tinkered with, but here we dealt primarily with well-formed and well-structured digitized documents, so we didn't really encounter that. But what it started out with was this one product with various features as required by our stakeholders, all built into one application. And basically, in that application, we had like a monolithic kind of a structure, and what we started realizing as we added more and more features was that the features were fairly independent of each other, and second is that they were basically making the application very heavy. So in the end, when we packaged our entire application in a container, it was about 7 gigabytes. Problem hosting it anywhere. Also, if it, for instance, there is any issue, difficulty debugging, restarting, and all sort of things. So we eventually broke it down into different steps, because we realized that each of them were also sequential. Like, we first uploaded a document, it needed some kind of pre-processing into well-defined data structures. Then we needed to vectorize it, get a numerical representation of the text. We had to think about the storage of these vectors, let's just say, and we had to also think about how to show them. We had to think about compliance and operational aspects. So we broke it down into these models into basically microservices, and that's what you see here. You see that the green boxes are microservices. First is the preprocessor, which basically ingests a PDF document and breaks it down into paragraphs. The second one is the vectorizer, which ingest these paragraphs and converts them into a numerical representation, in our case, a 512 dimension vector. And then finally, there is a ranker, which, given a query, matches against these blocks of text and basically gives us a ranked list of answers from the documents. And then we have the central app, which is the central orchestrator for all these preprocessor. It's a Flask service, basically built on top of Elasticsearch, which is just rerouting our requests. This is followed by the front end, which is in orange, and yeah, that's where the stakeholder interacts with our product. Now, moving on to some details about the infrastructure. Mickey?
Yeah, so as Anant briefly explained, we separated our application in three main components: the microservice with one in and one out, a web application, which isn't really something like dashboarding, but really like a full-fledged progressive web app. So you need some user management, user authentication, and of course a backend which tries to outsource all the heavy lifting, but does need some persistent storage and some business logic to make all the components work. So the infrastructure that we're going to describe here is also very based on these three main components. So try to briefly explain those three elements and how we deploy these without going too much into detail about, let's say, the specific departments and implementations within the organization itself, because they're quite abstract and can be found anywhere. And as you will also notice, maybe if you're working at ING, is that there are way more infrastructures out there than that we're just going to describe here and that we actually use for the application. So in the presentation you see here, you see the infrastructure itself mainly consists of the internet as a whole, but then the ING internal network as a place inside that network. And this is important because, you know, this ING network is not safe or secure or compliant in any way. So if you're going to host any application, you would need some more stuff on top of that. So that's where the touchpoint service mesh comes in. And it tries to deliver some rules and some standardizations to communicate in a secure and compliant way between applications. And this secure and compliant way for this touchpoint service mesh, at least, means that you would have to apply for an API. So you need to register your API, say, hey, I'm going to produce something, has 20 endpoints, or I'm going to consume an endpoint as well. And these things would go through the API marketplace. But you would also maybe need to solve the issue of tackling different types of distribution methods. So it could be distributed over multiple containerized applications on different machines through Kubernetes, for instance, or just a virtual machine that you are assigned to. And service discovery handles this by basically saying we're going to abstract away all these direct DNS or these IP addresses that you're using, and use logical connections, and they handle then the connection to the right machine for the right time. In addition, you would also have MTLS as a certification requirement. So you also would need to be able to communicate in a secure way. And this is where MTLS comes in. So MTLS is a mutual TLS, where both the consumer and the producer would need to confirm each other's identity. And all this leads into basically that you have multiple ways of communicating in only just the touchpoint surface mesh. So this is already quite a big requirement to start even communicating between different applications. So to tackle this, you also have something that's called a sidecar. And a sidecar is not like an application per se, but you can see it as an assistant or like a proxy that runs next to your application, tries to abstract away from all these tasks. And this could mean that you the sidecar will handle the MTLS certificates, the service discovery, and in this case, have the right configurations for this API marketplace. But it could also be that your applications exist completely outside of the scope of the touchpoint surface mesh. In this case, you would need to be able to communicate in a compliant way for the surface mesh, but also outside of the surface mesh. So what that means for our application is that we had a VM, so this was our central backend, and that runs outside of the surface mesh, but we needed to use or build a sidecar that could communicate within the surface mesh, because we also had a web application, which is a bit more than just dashboarding in our case. So we really wanted to separate the deployment of that and went for the front-end server delivered by a separate team. But that meant that this entire application ran inside the touchpoint surface mesh and would communicate only through the Nginx gateway, which in ING acts as the barrier between the internal network and the external network, but also many applications between that. And then we had our stateless microservices, or sometimes models, and these needed to scale a lot, so we wanted to deploy them on their separate machines in a scalable manner. And that also meant that we had to put it outside of the touchpoint surface mesh, but also had to communicate, of course, back to the central backend, which was placed inside of the surface mesh. Hopefully this gives you a little bit of an overview of how this infrastructure works, but you can imagine that you might deploy your microservices outside of the scope of the ING internal network at all. So it could be that you're running this on GCP, on the Google Cloud Platform. And in these scenarios, you would also benefit from having, for instance, a sidecar, because then you can place that one inside of the surface mesh, maybe a proxy that communicates through the gateway, and that way connect basically your applications together. So further on, we're going to discuss deployment of these three services. And what's good to keep in mind is that all the steps that we basically do relate to connecting these applications together. Of course, there are many different journeys depending on the infrastructure that you choose. So I'll leave it to Anand.
Yeah, thanks, Mickey, for the very succinct and clear description about these wide array of infrastructure concepts. The building block of our application was, like I mentioned previously, a microservice, which was, let's just say, basically a very independent aspect of the product itself, which we broke down into, or a model, let's just say, which we spun off into a different service itself. And the core concept of this was that it was receiving one kind of input and it was producing one output, and we needed a place to host it in the cloud so that it is scalable and fault tolerant, and we also got some individual monitoring on them. And then therein basically came the machine learning platform, which is a squad within our organization, which helps taking machine learning models to productions. And because all of our models that we mentioned here, the preprocessor, the vectorizer, and the ranker were machine learning models, we naturally turn to machine learning platform. So what they provide to us is basically they provide us the infrastructure and environments, they provide us the CI/CD, they provide us the networking. So they also have their own sidecar basically, and they all these machine learning models run behind this sidecar. So they're back then we had some TPA issues with them, but let's just say right now they're TPA compliant. And so they facilitate this connection to the service mesh that Mickey just talked about. What they don't provide is development and integration. Of course, that's our job. So they abstract away all these concepts, and as data scientists and engineers, we're just focused on developing our model. So, and for local development, they provide us with a sandbox CLI version, which basically helps us to do some integration tests, which lets us run our models locally behind their sidecar to ensure connectivity and to ensure that the payloads are being processed through the sidecar, for instance. They do provide the TPA connection now, like I mentioned. So TPA is the touchpoint architecture. So they provide a connection to the touchpoint service mesh. So in case we want to use some other microservices or models hosted there, we are allowed to. And they are very suitable for stated microservices, one in, one out kind of models. But now they're expanding, which we will cover in the next slide. This is their architecture as it stands now. They call it the United Model Platform or United Execution Platform. And basically, as we can see, that there is a centralized machine learning platform interacting with different components. When we deployed via them, they were providing CI/CD via GitLab, but with the organization moving to Azure DevOps, they are now moving their pipelines to Azure. And like we see that they provide these different lambdas, which are the model itself, and then we have the feature extractors, which in our case, for instance, was the preprocessor, because how it was different was the rest of the microservices received map data structures, dictionaries, pandas data frames, if you will, whereas our preprocessor received a binary, which was a bit of a issue back then, but now it has been resolved and it can happily accept binaries, basically. It also has some metadata support. And so they have built this support for these feature extractors as well. For instance, another use case can be that our preprocessor needed to connect to a blob store, for instance. So all of that is covered here. Back then, and as we will cover in detail when we are talking a bit more about the central backend, is that we chose our own asset, our own VM for deploying the central app, because the machine learning platform did not have a support for multiple endpoints, API endpoints, but now they are providing that. Lastly, they are also going to be, and like I mentioned previously, they will be providing for the monitoring and logging of our applications, as well as the touchpoint registration of our microservices. But they will also provide as an or act as an interface to for services running on GCP. So they will facilitate running of models on our private cloud, but also on GCP if needed. And also everything that is hosted on GCP, we can interact with those models or those services via the machine learning platform. Next up, we will talk a little bit in detail about the central app, which we deployed on our own asset, which was a VM on our private cloud. And yeah, Mickey?
Yeah, so moving forward then to the deployment. You could go to the next slide, please. Yeah, so to recap, basically, our central application was a central backend that had no expensive task, as you could say, but didn't require some persistent storage. It was basically a Python application with running Flask, containing all the business logic. And we chose for this solution because we had this complex networking requirements of communicating both to the front end, which was on the front end server that had to go through the gateway. That was an Nginx web server. And it had, of course, communicate to all these models, which didn't have one specific, these were all stateless. So you needed to connect to something because the front end couldn't do this all by their own. So this solution, what it basically entails, you can go to the next one, was that we had to, so this meant that we need to be TPA compliant because, of course, the VM doesn't exist within this touchpoint service mesh, but the front end did. So that meant that the entire backend needed to communicate in a TPA compliant way. So for us, that meant setting up a sidecar, and because a VM is just really like a duplicate machine, you could see this as running our application, which was the Python application, and then the sidecar in our case was a Java applet that runs on the side that acts as the barrier between all communication to the outside world. And we'll go into detail a bit about that later on. So this meant that CI/CD was our responsibility, and networking as well. So I'll briefly explain what this deployment road looks like. And this is really from the bottom up to full production, basically, with, of course, all the operational stuff left out and all the compliancy. But that means for such an IT asset on a VM, you would need to, of course, have this machine. You would need to have all your required dependencies on there, and then do the required registration of your application to get the right certificates, because this is required for the touchpoint service mesh as well, especially for MTLS. And here in the middle, like these are the 5 steps, but in the middle you see basically the CI/CD part, which we did through GitLab and Artifactory. You could, but nowadays you can replace this quite easily with just a CI/CD pipeline from Azure DevOps. And this could directly push basically to your VM or any other solution that you would choose. On the right side, you would see basically all the networking requirements. So this is the API and service registrations and setting up the certificates. And this is basically the most work, because this is setting up the entire sidecar for being TPA compliant. And this is required if you actually want to do this deployment for yourself. Because of the time limitation, we don't go into too much detail right now what it means for the actual steps, and we have documented everything. So if you would like to see that, we can share that later on as well. But I think the more important part is that you would grasp a little bit on what it means to configure a sidecar, or what the sidecar actually does. So if you do have to do this, then here exactly on the right, you can see basically a very basic configuration of a sidecar, and this explains quite well all the key elements of your touchpoint service mesh requirements. So all the way on the top, you would see that the application is in the producer. So this means that the central backend produces some APIs for others to consume. And we're using basically the application on the same machine as our own application that we want to serve to users. So all the way at the bottom, you see the mesh port, and then all the way at the top again at the server port, you see the ports that are basically meshing each other together so they can freely communicate to each other on the same machine. You also see some SSL part here, some configurations. These are all the keys in the store, so you can see this as being your assistant. So the trust store is saying who are the people I can trust, and you give them maybe a social security number and a picture, like only talk to these people. And then the key store is like the confirmation who they or who you actually are and who they are. But the sidecar can be more way more than just basically a way to be compliant on the touchpoint service mesh. So you can also see somewhere below that you can enable some metric support, so that the sidecar would already have support for logging capabilities through Prometheus, or maybe some other services as well. And yeah, that allows you to basically abstract away as much as possible with such a simple application. Unfortunately, if you do have to build this from scratch, you can quite easily isolate this entire application or Dockerized or just as a Java application. So it runs basically on every environment. So for us, this meant that the deployment road was a bit more difficult than it is now, because it was actually almost a year ago that we did this. So for us, we did it through GitLab, and then pushing our CI/CD through Artifactory, and then manually pulling it on a on-demand basis to the VM. and then it would work. But of course, with DTAP, like with test acceptance and production environment, this is becoming a bit of a hassle. So we recommend, it's well documented now, to basically make full use of Azure, because your entire pipeline can quickly go through the CI/CD there without so many external dependencies. And then, yeah, we also have our final part of the application, the front end. And I'll keep it a little bit short here for the front end, because yeah, not everyone is too much interested in that, and we can have a whole talk about it in a separate meetup. But what's important to know here is that the application I'm describing is really a web app, or a progressive web app. So it can run without internet if you like, but more importantly, it has state, it can have user authentication, and it works in an ING standard way. So this is even not just by ING standards, by most internet standards nowadays. Web components are becoming more popular, where you can really abstract away from all the applications you're building, try to keep it really small and tiny, and then share them around in a plug-and-play kind of way. It also allows you to really reuse a lot of your elements that you're building. But for the networking part, we were fortunate to have, let's say, an existing infrastructure in place. So this is the front-end server, and that is because the front end is really tiny. It's like a static website once it's built, and it does mean that it's a bit unnecessary to host another VM, of course, and register your DNS for that, because you're never gonna fully make use of basically that VM with just a static website. It's just a few kilobytes that you need to send around to each client request. And that means that you can make use of some pooling, of course, so deploy everything on the same server and then handle the internal networking on that side. So we did that through the FE server and Fruit Loops, but that came with the requirement of communicating through this Nginx gateway.
All right. So thank you, Miki, for the very long discussion on the back end and the front end. So some parting words as we close this talk. And this is primarily useful when we are deploying some data science models, particularly, and especially when we want to deploy like multiple components of them as microservices, and basically when we want to make them, fault tolerant and easily scalable. So some of the things that we found useful and we will keep in mind for our future development, and we just want to share with that. So first, share with everyone here. So first and foremost, we really urge everyone who is looking for this kind of a development to get a Hello World app running ASAP, using some kind of Jenkins or Azure DevOps pipelines, whichever is running in the organization or is of the preference. We should always keep scalability in mind. So that's why we urge everyone to work with microservices, because then it's really like your application is decoupled, and really one service cannot bring down the whole stack. And it would be nice to deploy via some container orchestration instead of a VM. This allows for like free scaling and really good fault tolerance. For some persistence and storage, we would prefer using binds and volume mounts, and we would encourage everyone to use that as well. We found them to be really helpful in our case, especially with some kind of document management, etc., and blobs. Most important thing that we realized was how essential it is to work with centralized services. So whether it is a Redis database or an Elk storage or whatever, it is nice to reuse centralized services. They are already built for scale, and it can be a bit of a pain to onboard onto them and the operational aspects, but the rewards are very good. And like we discussed quite a bit through our entire conversation, that we should really think in detail about networking and security of our application. So we should really think about what kind of internal applications we are going to connect to, what kind of blob stores we are going to connect to, what kind of external network connections we have to allow, like to a front end or to a application hosted in GCP. Whether we are just going to produce, we are going to operate in a producer mode, or whether we are going to also operate in a consumer mode. So we have to think about all of these things, and accordingly the security part and the networking part. Then finally, we did for instance, we did manage to set up some monitoring stack for our services. But yeah, it is also important to think about that. So what are the things that we want to monitor and how are we going to monitor them? Because we don't think about it, but it can take a significant amount of time for a developer or a squad. And lastly, yeah, we like to do it at ING, do your thing, and have fun developing your applications. Thank you very much.
Thanks a lot, guys. Well, we mainly have a lot of emoticons applauding your talk, and they're very enthusiastic. So thanks a lot. We have a question from Ali. How much or how long did it took you guys to go to production?
Miki.
Yeah, so I think one of the production timeline was really split between the applications. So once we went to, let's say, this microservice type of architecture, we could really isolate the deployment of each of these production roads. So for the front end, that meant that once we were basically in a test environment, we were also quite ready to go to production. So of course there were some feature requests besides that. And the same went for our model deployment. So the biggest bottleneck here was taking up the responsibility of using this VM and connecting it basically to all these different systems. So without that part, you could say theoretically it could have been done in 3 weeks, but for us we went into a usable, I think only testing phases after roughly a year almost.
I mean, like the core work, I think for all of this was 6 months. A couple of months I also went in, for instance, monitoring and all these things. But like I said, like the core engineering part, including all the networking certificates and operational aspects, took about 6 months, I think.
And if you talk from idea to production, so from the first idea moment to go into production, how long did it take you?
Well, the POC was really fast. I think we managed to develop the POC, including all the feature requests and everything, in like 3 months. And then, yeah, like I said in the beginning of the talk, that it was all monolithic. So another 1 month of breaking it down into microservices. So in like 3.5, 4 months, we were ready with the deployment. So our local POC or MVP even was ready. But getting it into a cloud was the real challenge.
Okay, thank you. Yeah, more thanks, guys, more emoticons. So let's give it a few seconds to see if anyone else has some questions. Again, nice work. Thanks for the display. I think we have some ING colleagues who are thanking you as well. I think we have a big ING crowd today. Yeah, I don't see any other questions. So thanks a lot, Miki and Anand, for your talk. Really interesting. Yeah, so I think we will go back to John, who will introduce our last speaker from Go Data Driven.
Yeah. Hello, everyone again. Anand, Miki, thanks for a great talk. But now it's my distinct pleasure to introduce Fokko Driesprong, who actually used to work at ING together with me in our team on a product that is still running. So good job, Fokko. But Fokko is a principal code connoisseur at Go Data Driven, helping companies to set up data infrastructure and build data-driven products, like he did here. Next to that, he's an open source fanatic and committer on Airflow, Parquet, Afro, and Druid projects. Clients include Booking, Royal Schiphol Group, Royal Ahold Delhaize, eBay, Classifieds, and last but not least, us, as I already mentioned. So he's now going to give the following talk: democratize your pipelines with the data build tool. Fokko, I'm looking forward to it.
I was still on mute. Thank you, John. Yeah, happy to be here. Yeah, so today I'm going to talk about DBT. It's a new technology that I'm very enthusiastic about and would like to share that with you. So it's called democratizing your pipelines because if you use DBT, your pipelines become much simpler to build and to maintain. I think John mentioned that we worked at ING. I think DBT would be like a perfect addition to the stack that we used back then, but it was not around at that time, unfortunately. So a bit about me. I think John mentioned the most of it. So this is me skiing last year, no skiing this year, unfortunately. So I have a background in distributed systems and software engineering at the University of Groningen. I'm a code connoisseur. So at Go Data Driven, you can think of your own title. So this is what you get then. I'm a big open source enthusiast. So I'm a member at Apache Software Foundation, the big non-profit organization that governs a lot of the open source projects. I'm a committer in PMC on Avro, Druid, and Airflow. And a committer on Parquet. So if there are any bugs in there, I'm sorry. This is my email address. So if you have any questions, please drop me a line. So the obligatory slide about Go Data Driven. We're an Amsterdam-based consultancy company. We're doing mostly data engineering and data science. Also involved in data strategy. And now we're also doing analytics engineering. So this is a new upcoming role that's also very involved with, for example, stuff like DBT, building analytics pipelines in the cloud using modern day software. Around 50 consultants. Used to do a lot of Hadoop. Now everything is shifting to the cloud. And if you want to work, just drop me a line again. So let's go to the core. So let's talk about DBT. It's a short for data build tool. And it's very important that you spell it lowercase because that's how it's spelled. Otherwise, you get a lot of critique on the online. So as you all know, building data pipelines it's quite hard, right? So you start with a data lake, you start ingesting stuff. You're with a big team, and you have to coordinate stuff. It's very easy to turn this data lake into a data swamp. You want to get started and you want to build stuff quickly. You have stakeholders wanting to have access to the data. You forget stuff like data governance, data lineage, data ownership. That's super important. It's also a requirement nowadays, so you cannot even skip it. But it's easy to go over this. I think DBT is a nice tool that helps you implement a lot of these things. It applies structure to your data. I always tell it it's like an implementation of data ops. And data ops, it's maybe a new tool or term, but it's like a derivative of the DevOps that we know from software engineering. And I think a lot of these concepts from the software engineering that we see in DevOps, you can also implement it in when you're developing your data pipelines. So you have this cycle here where you make incremental changes. You apply tests, you build it continuously. You deploy your data pipeline a couple of times a day, and this is all captured in data ops. So how we see this at DBT, and I will come back to this later on. So the code is all SQL. You have the build step, which you do with DBT compile. You have the test step, which you do with DBT test, to make sure that you're up to standard with your data quality. Release is going through Git, and deployment is just Docker. So no weird UI, it's all code. And to run it, you just do DBT run from your command line or from your CI/CD or from your Airflow orchestration or whatever you're using. Your Azure Data Factory, if you will. So what is DBT? So DBT is part of what they call the modern data stack. This is a quite interesting movement going online. It's about what they call the modern data stack is like using a lot of stuff off the shelf. So we used to build like a lot of stuff on our own because it was not around. For example, if you want to ingest data, you would write some fancy Spark program. But nowadays you see like that you have a lot of tooling around. Like for example, Fivetran. If you want to have your data from your Google Analytics into your BigQuery, you can write this yourself. It will take you a couple of months, maybe a couple of weeks if you're fast. And then you have everything in there. And then you forgot the column, you have to go back. So this modern data stack focuses really on having like more off-the-shelf kind of tooling that will help you to hit the ground running. DBT is a tool for compiling and running data pipelines. So it's actually a combination of a compiler and a runner. And we'll go into more depth later on. And it's a simple tool to build complex pipelines. DBT itself is quite simple. I think that's the powerful part of it. So often you're in a very complex environment. If you look at ING, there's a lot of terminology. You have a lot of, if you look at the data sets, there's a lot of context, a lot of organizational knowledge built into this data sets and also the data pipelines. And that is where the complexity is. So if you also have like a complex tool, then you have complex times complex, and it's going to be like maintainable. So I think one of the powers of DBT is like, because it's so simple, it allows you to have to operate in a more complex environment. It takes the best practices from software engineering. So if you're a software engineer, you will definitely like DBT, and you can do stuff like linting and do your classical pull request, have testing not on your code but on your data, and the dry principle of don't repeat yourself, so you don't have to rewrite the code all the time. So it's also quite opinionated. One of the things is that it's SQL only, and I was a bit afraid in the beginning, but we used this at several clients, and from practice I can tell that most data pipelines you can just express in SQL as well. Why is this so important? So this is how I see it. This is not based on any scientific evidence, but this is my perception of my consultancy life. You have the very tech-savvy Scala developers, but you only have a few of them, and they're extremely smart and write Scala all day. On the other hand, you have like the SQL developers, like the most business analysts nowadays can maybe write some SQL or maybe use at least some low-code kind of tooling to do their data analysis. And actually, like I said, a lot of the organizational knowledge that's inside of the data sets, and you don't want to transfer this all to the Scala of Python developers that write your pipelines, but you actually want to push it down so that also the people that do the day-to-day business with the data sets, that are also able to encode this knowledge into the data pipelines. Also, when you look at it from a more computer science perspective, Scala and Python like imperative languages. So if you write Python, you write what you're doing, and with SQL, it's a declarative language. So it also you actually write what, with imperative how you do it, and with SQL it's like what you do. So you select star, then it's much different than with Python. Because it's declarative, it's much easier to also analyze. So you know how the pipelines runs, which data sets you're using. So it's much easier also to do static analysis on that. And that's very interesting, I find personally. So DBT on the hood. So DBT, it emerges actually from the data warehousing side. So it has first-class citizen support for Postgres, Redshift, Snowflake, and BigQuery. So it's also mostly cloud-based. It's created by Fishtown Analytics. It's a Philadelphia-based company. They raised like 13 million in the A series and 13 A series, 30 in the B series. So it's got a lot of funding. I think that's also it shows the interest in the tool, also by investors. It's a huge open source community. So if you have any questions about DBT, you just go to the Slack, and within a couple of minutes you have like a response. It's a very active community, which is very nice. It's distributed on the Apache 2.0 open source license. So if you want to relabel it and want to sell it, you can do it. It's just Apache 2. And it has like a lot of second-class citizen support. One of them is, for example, Spark/Databricks. So Databricks is the managed Spark. It also has support, for example, for Athena or for SQL Server or for, so everything that talks SQL, there's probably like a DBT plugin for. And the nice thing that I find, like I'm a developer, with Postgres, Redshift, Snowflake, and BigQuery, everything works out of the box. With Spark and Databricks, you sometimes have to do some open source activity just to fix some of the nitty-gritty bugs. So how does DBT fit into the stack? So this is like a schematical overview. On the left-hand side, we have like the data loaders. And these are like I mentioned, like Fivetran or Stitch. They are like a SaaS software to load data from all kinds of sources. It can also be some kind of Airflow job that takes the data from your ING mainframe, or maybe schedule some jobs to do the OCR that we saw earlier today. And then it will dump all the data into the raw data that we see on the left-hand side. And what's important here, once it's in the data warehouse, it should be like structured data. And so from when we take the example from earlier today with the OCR, and you go in with the PDF, which is like unstructured data, and what will come out of this data loader is then like a Parquet file with a couple of columns that describes this PDF. And then we go into DBT, and we end up with transform data, which can be like a source for your BI tooling, but also for the input for your models. And you can also do like feature generation, this kind of stuff, all in DBT. So it shows the standard data warehouse that is supported, but also Hive and Apache Spark. And Hive is there because you don't do any Hive SQL, but you use the Hive Metastore for the managed tables. So how does this look like? On the left-hand side, we have the base. So these are the tables created by the data loaders because you don't see anything in front of it. So these are the tables that are being unloaded onto the data lake using your data loaders. And then you can have like a pipeline where you refine the data. So this is the base. Then you combine these two into staging app orders, staging Shopify orders. You can probably union these two into all orders. And then on the right-hand side, you have the fact orders. That's coming from all orders and staging customers. So this fact orders is the fact orders.sql. So this is what they call a model. And when you do say, select some fields, you say from, and this is like if you are a Python developer, you will probably recognize this. This is a Jinja templating where you say ref all orders, which is this file as orders, and then left join ref staging customers here. So this is how you express your transformations in DBT. So it's all SQL, and you use the ref to point to other models. So why is this so powerful? Like I mentioned, DBT is like a compiler. So when you run the thing, if you do DBT run, it will fill in these. It will compile the SQL and fill in the actual table and database names. So let's consider a very simple a pipeline that we here have, like staging beers. We convert this into fact breweries, into fact styles, beer styles like IPA or bit beer or whatever you like. And this is also the lineage graph that comes from DBT itself. So it has like built-in documentation. If you do generate docs generate, you do doc serve, it will start like a local browser, but you can also do like docs generate and host this in with Nginx or put it into a bucket somewhere so everyone in the organization can see the whole data catalog. And this is how you express it in SQL. Then you see like, hey, if you do DBT init, you will just get this structure, and with the models where you can say, okay, we have this fact breweries, which is this one, that does like an aggregation, takes the brewery and does some average, compute some averages, grew by brewery from staging beers. So this ref, when you run it and you look into the compiled directory, and you can actually see that it will be filled in on compile time. So in this case, it's very easy to make, like, for example, like a staging environment and a production environment. And this makes it very easy to have like different environments. So if you're working on the data pipeline, that you're not messing with the production data, it's all, and you don't have to do weird stuff with your Airflow, but you can just get it all of this out of the box. What we often do when we have like a nice CI/CD pipeline, and we just inject like the branch name in there. So if you have a team with 10 people, you never have to wait on your colleagues because they're working on staging or whatever. So if you then do DBT run, it will actually execute the whole pipeline. If you see here, we have like 3 models, It will start with the first one, the staging beers. Here it will start it, run. It is finished in 1.27 seconds. And then it will run the second two in parallel. So it's also the notion of parallelization here. If you run everything into a notebook or whatever, that's often a bit more difficult. But dbt it resolves the graph so it knows which jobs it can run in parallel. And this will be run in your Spark backend. If you, for example, use Databricks, then if you go to your staging database, you will see the tables there. So what I personally find very powerful about dbt is the annotation of the models. So we have the schema.yaml. So there's a YAML file that you put into the same directory as your models. You can give it a name. In this case, staging beers. It's equal to the SQL file name. You can give it a nice description. You can give the columns here, like beer, the name of the beer. So you build like this organizational knowledge of the data. What does this column mean? You encode it into the pipeline itself. So often you see this being put onto some kind of Confluence page that's always out of sync with the code. And here you just you put it next to the actual transformations, so it never gets out of sync. So we have a couple of more columns. Then we have the state, and here you can say, okay, for example, we have a test here with accepted values, and if there's a state that's not in these values, it will give an error when you run dbt test. So in this case, we say the beer. So there's one of the columns say not null, and it should be unique. Can the beer name be unique? So if you run dbt test, it will run all the tests also in parallel because there's no dependency on each other, and it will tell you the unique beer name. And this test, it failed. There are 82 violations, and it will tell you where the SQL is, so you can easily rerun the SQL and find out which ones failed. So this sounds very trivial, but it's actually quite powerful. So if you work in a team and everyone is changing the pipeline, then you can have some constraints on the data just to make sure that everything keeps sane. So typical tests that you can execute are not null, uniqueness, accepted values that you just saw, but also referential constraints. So if you have, for example, an order that has a reference to a customer, and this customer doesn't exist, then it can throw an error. And these are the typical things that you see in a data warehouse, but are not available in a data lake. Data freshness. So if you say, we should expect this table being updated every day, you can assign a column that has like a date in there. Say, okay, this should not be older than 2 days, for example. And you can say custom test. So if you have some, if you want to compare some columns, maybe add some orders and compare it to something else. And like I mentioned, it will when the test fails, it will tell you which test it was. It will tell you which test failed. So you can just copy this, put it inside your notebook, and just run the SQL, and then you can see that these are duplicate. So probably, there's more than one in there. It's of course perfectly possible that the beer name is not unique. Would like to stress that this is all code. So if you change something, you just have to go through a pull request. Typically with these kind of tooling, you see that it's like some kind of GUI or no pull request kind of stuff that you can do. I think it's super important because if you change the definitions of your columns, then you should also notify your colleagues, right? If you change something in the pipeline, then you should discuss this with your colleagues. And I think pull request is a very nice way to do this asynchronously. So you don't have to have a meeting all the time, for example. So I really like this. So the moment that we've been waiting for, some live coding. So this is just the code that we had. So let's for example just add like a new model in there. Let's call it fact beers. So I live in Haarlem, and the GoDaddy-driven office is in Amsterdam. And with these Corona times, I often go by car. But you cannot drink too much, of course. You shouldn't. You should even not drink at all when you're driving. But yeah, I just want to know like which beers are safe, just to drink one. If I have to go by car. So we go to the staging beers, and we know like the ABF. It's like the alcohol percentage, and we know how big the beer is, so we can actually check like how much alcohol is in there. So maybe this is a nice thing just to write for now. So we do select with. Let's just do select star. Oh, what's this? Macro. Then we say ounces. Yeah, I'm not from the UK, so I'm not really comfortable with ounces. Say ref staging beers, right? Let's make a small macro. Say OZ to milliliter. But this is like the dry principle where you don't want to repeat yourself. We say OZ to milliliter. Column name macro. And you say there's all the Jinja templating that I discussed earlier. So this is just like a Python, well-known Python library. What is it, like 5735296-ish? So now we have like, if you have any models where we do this transformation, we can reuse it. And we can say like, okay. We say like, Ninja templating again. Milliliters. Good. Nice common table expression. Star from I think this is something like this, like 2 beers. So depending on like how big the beer is times the alcohol percentage, you're still allowed to drive. Right? So you go to the schema.yaml, say because I think I'm of the belief that YAML is not meant for humans. Say the name of the. I don't want to take any risk here. Let's say like test should be not null, because we should always know this, right? Otherwise, you should not drink. Maybe not drink at all. And then we can do dbt run. Now it found 4 models, so we have like a new model. Make it a bit bigger. So now we see that everything ran. So we go to our Databricks environment. And we can see that we have the new column. So we have the volume in ounces and the milliliters. It's like I can. Then we can say WBAA test. Now it will execute all the tests again. Oh. So now we see there's the uniqueness, one that failed, and 62 one of them are not null. So I actually know that the ABV, this one, it's sometimes null. So we don't know how much alcohol is in the can. So in this case, I would say, okay, maybe we have to go back here. So we say or less, right? If you don't know, then we say false. So if you don't know the alcohol percentage, then we say false. If you rerun the pipeline and we rerun the tests, then it should pass. I think that is like an illustration of the iterative way that you run these models. So you write some pipelines, you add some tests to it, and then everything should pass. And if not, then you should fix it. So you actually keep control of your pipeline. And I want to stress once more, like if you write your pipeline by yourself, then it's very easy to keep everything inside of your head. But if you're especially working with bigger teams, everyone is changing the pipelines. Then you want to have some tests in there, just to make sure that everything still works as expected. And you would say like git diff, like check everything looks good. Say then I can assign a colleague to it, just to review it. So small recap. So you write all your code in SQL, but still being executed by, for example, Spark or your favorite cloud or on-premise data warehouse. I personally really like SQL. I think it's super powerful. If you cannot express in SQL, maybe you can fix it with UDFs. Otherwise, it becomes a bit troublesome. You run dbt compile to check if everything works. Dbt test to check if your data still data constraints still hold. You do your release and deploy using Docker and Git, and you just operate it using dbt run. So you can run it locally just for development, but also in your nightly run, for example, you can run it from your Airflow instance or whatever. That's it from my side. Hope you've enjoyed the talk.
Well, Foko, for once, I'm very thirsty now, so let's see if there's not too many questions so we can get to the beer. But there are some questions already. The first one was from Robert Morline. He asked, AWS, Google, and Microsoft all provide cloud tools for like supported by the same provider. Would they not include capabilities like this going forward in their tooling, this being open source?
Good question. Yeah, I think it's more than just running SQL. So it's not only in BigQuery, you can also do something similar, but having these DAGs and also developing like in this iterative way. I know that Google just recently bought like a company that does like similar to this, but I think it's not widely available yet, and it's fully open source, so you don't have to pay for it. You can just run it in your local CI/CD. You can easily Dockerize it, so it's very complementary to the existing stuff that's already in the cloud.
Thanks. Another one from Joost Bloem. Nice talk. Is it only for batch processes or also streaming use cases? And how does it compare to Apache Beam or the GCP service data flow?
Good question. Yeah, so it's batch focused. So there are some stuff that I did not cover. For example, you also have the incremental imports where you can do like for example, like an hourly run, but it's all batch based. Yeah, so you can do micro batching, for example, and let's say you run something actually every 5 minutes. It's also very You can have it's fully support to incremental runs, but it's just batch based. Yes.
Okay.
So it compares to data flows like that. You also have the batch layer in there, where you can also do incremental stuff. So it's a bit complementary, I would say. Yeah.
Okay. Thanks. I don't see any additional questions. Ahmed really liked your talk. I also spoke to Daniel just now. He also mentioned that this would have been a great tool when back in our days developing the product that we used to do. So at least you have a few fans here, another happy people there in the crowd. So thanks very much, Foko. And I guess you're already at home, so you can drink any of the beers.
Exactly. Thank you.
Thank you very much, Foko.
Yeah, so this is was the last talk. So time flies. I think, John, I would like to thank all the speakers for their very interesting talks. Yeah, from both of us, thank you very much. We have one last contribution we want to give to you. So if you're interested in ING, you're curious about how you can follow us or everything that we do in the field of data engineering or data science, or you're interested maybe in working for ING, then we have a last contribution from our colleague Nicoletta. So the floor is yours to tell them a little bit more about that.
Yes, thank you, Jesse and John. I would like to leverage this opportunity and mention a couple of things about my team, Wholesale Banking Advanced Analytics, or WBAA in brief. So we are a multicultural, diverse and inclusive ING tribe growing in 4 different locations. We develop algorithmic data-driven products and are very proud of our unique culture, since we love dedicating time and experimentation, and we care about initiatives that go beyond banking. So if you wish to learn more about us, you can check our Medium blog, including a nice mix of business and tech content, plus a wealth of engineering blogs, but also make sure to check our ING Tech blog with content from our colleagues across the organization. Now we want to make it happen with top talent. So if you're interested in joining the innovation frontrunner that ING is, you can check our careers path for openings in engineering or positions such as data science chapter lead or roles in NLP and chatbot. Now, if you're a fresh graduate, check our traineeships, including the analytics traineeship track. And that's it from me. Thanks for attending the first data engineering meetup of 2021 and looking forward to the next one. Back to you, Jesse and John.
I think Daniela was looking for me in the overview. Thanks.
She was, yes.
Yeah, so thanks again from all of us. If you are more into data science or you want to catch your next meetup on 18th of March, we have our data science meetup. So be sure to RSVP on meetup.com. And I think I want to wish everyone a nice afternoon. John, do you have any closing words?
Well, the closing words, if you want to rewatch any of the things that you just saw, that'll pop up on the YouTube channel that you're now watching as well, live. Like Nicoletta mentioned, there are a lot of blogs. Look at ING/jobs if you're interested in joining us, and we'll hope to see you next time.